Imagine this. Pitch black night, no horizon, no city lights, just an endless ocean below. And above it, 300 tons of metal suspended in the sky. What keeps it alive? At 35,000 feet the air outside is deadly. There is not enough oxygen to survive, temperatures can drop below -50 degrees Celsius, and the pressure is so low that the human body cannot function. Yet inside this aircraft people sleep peacefully, children watch movies, cabin lights glow softly. How? Because survival up here is not natural, it is engineered. Every second thousands of invisible processes work together. Air is compressed, temperature is controlled, pressure is stabilized. Without cabin pressurization there would be only seconds before consciousness fades. What keeps 300 tons alive is not just power, it is control. Look at the wings. They are not rigid slabs of metal, they flex, they bend, they adapt to turbulence. In a storm the wings move with the air instead of fighting it, and that flexibility prevents structural failure. Outside lightning flashes through towering clouds, rain lashes against the fuselage, the ocean below reflects nothing but darkness, and still it flies. Inside the cockpit screens glow in cold blue light. Data streams constantly, altitude, speed, wind direction, engine performance. Hundreds of computers process information faster than any human could. If one system fails another takes over, and if that one fails there is another backup. There is always redundancy because at this altitude there is no room for error. But technology alone is not enough. Two pilots sit in front of those displays, trained for years, prepared for scenarios they hope never happen. If automation disconnects they take control. If instruments fail they rely on memory and discipline. If everything goes dark they still know what to do. What keeps 300 tons alive is not just thrust. Yes, the engines generate enormous power, pulling this giant forward through thin air at nearly the speed of sound, but thrust without guidance is useless and power without structure is chaos. What truly keeps it alive is the balance between physics and precision. Lift counters gravity, thrust overcomes drag, weight pulls downward, design pushes upward. It is a constant battle of forces, and the aircraft wins not because it is stronger than nature but because it understands nature. Aerodynamics, pressure differentials, advanced composite materials lighter than steel yet incredibly strong, decades of engineering evolution, millions of hours of testing, failures studied so they never repeat. Now imagine the worst-case scenario. Electrical systems fail, screens go dark, autopilot disengages. Outside there is only storm and night. In that moment what keeps 300 tons alive? Training, discipline, human decision-making. Because at the end of all automation there is still a human mind. An aircraft in cruise looks calm and effortless, but beneath that calm surface there is constant correction, micro-adjustments in control surfaces, fuel balancing between tanks, continuous communication with satellites and ground control. Nothing about flight at this scale is passive. It is active survival, and yet to the passenger it feels simple. That is the illusion of perfection. The greatest engineering achievements are the ones that hide their complexity. So what keeps 300 tons alive in the darkness above an empty ocean? It is not just engines, not just computers, not just pilots. It is trust in physics, trust in preparation, trust in systems built to never stop thinking. Metal does not live, but when engineering, intelligence and discipline merge, it feels alive. And that is why in the middle of the night, over an endless black ocean, 300 tons continue moving forward, not by accident, but by design.